In this tutorial we are going to derive the formula which is number 2. Actually, let's just write that in for Suvat 2, and we are going to use a combination of the other 3 to enable this derivation. So let's see how we're going to do this with substitution and simplification. The first thing I'm going to do is I'm going to use number 3 as my starting point, which we've already proven. So v squared equals u squared plus 2as. And then I'm going to, that's number 3, and I'm going to sub 1 into 3 with the v's. So what I'm going to do is we're going to lose the v squared, and we're going to put v equals u plus at, so in its place. And then we're going to just carry on and write it out, u squared plus 2as. The next thing we do is multiply through and do a bit of rearranging, and I've ended up with 2as equals u plus at squared minus u squared. Now I'm going to square the brackets first with FOIL and combine them and merge them at the end. So 2as ends up as, using FOIL, because I just bracket those out, I end up with u squared plus uat plus uat plus a squared t squared, and then don't forget the minus u squared at the end, because what's really great is I can just come along and cancel, so I get left with this term in the middle. Now all I need to do now is get rid of the 2a, and I end up with the final, because we want to get it into terms of s. So to get to s, I'm just going to bring the 2a under here and divide by 2a, which gives me, hold on, get my pen back, it gives me s equals 2u at plus at squared all over 2a. So therefore we cancel out the a's gone, square's gone, just to give us an a, and that gives us, just to neaten it up, because we've actually done it, I'm just going to say in simple terms it is this. And now I'm just looking up, is that correct? Always check when you're doing this. ut plus half at squared, boom. 2.